Um, Today we are going to be solving this question named validate BST, binary search tree. This is a very famous interview coding question. So today I'm going to be discussing this as a perspective of if you're giving an interview, how should you approach this? Okay. So for someone who doesn't know what BST is, it's very simple. So as it said, every node, so the left value of every node should be the smaller than the node value, and the right value would be greater than the node value. And that should be true of all the child nodes, right? So, if you have solved binary tree question of any kind, when the interview asks you this question, the first thing that comes to your mind should be, what kind of traversal would you want to, do in this case? Is it an in order? Is it a a level order, what kind of, and do you want to go recursively or not? So okay, so to validate a BST, if you think in a recursive way, the first thing that should come to your mind is, for every node I should check, hey node 2, is your left value is less than you? If it's less than, okay, check right value, is your right value greater than yourself? Okay, then this node, this particular subtree, this tree itself is a small tree, but let's say if this is of length 3 only, this level only, so we can say that this is a valid BST, right? But what happens when there are a lot of trees, multiple trees? So recursion is all about, delegating the work. So, 5, when we are in node 5, check, hey, node 5, is your left value is less than you, if your right node is greater than you, if so, recurse on your left child, recurse on your right child, right? That's the basic terminology here. But one thing to notice here is, we'll how will we know, if the current node that we are at, so how would we know, there should be a value which we are recursing, to say, the particular node should be less than that value. So the thinking here is, why don't we maintain a local, you know minima and maxima for, for every recursion that we do. So let's start from, building a helper function. As the name suggests, it will help us in solving this code because we need more arguments. So the first thing that it's going to accept is tree node root, right? And the next thing is a value, min value, and the next thing is a max value. Okay. Okay. For every recursion, you know either you can think of the base case in the last, but at this point, everyone knows that, if we are at a root that is equal to null, so we just, you know let's say if we have one node, that's null, right? Or if we reach at the end node where the, let's say we did a lot left and it came to null, it should be true. This doesn't affect our functionality of the binary search tree, so we'll return true. Now at every step, if you think, let me first do the recursion, what we'll do is, then I'll write the if statement. Okay, so we will say, hey, recurse on my left child. So helper, go on to my left child and ask if, for my left child, is the BST valid or not. So the min will be as it is, but we'll update the max as the, not in min, we'll update the max as the current root value. I'll tell you what exactly it means. So let's say if I'm on a root node 4, right? So if I'm recursing on my left child 3, let's say there are some more nodes around this, right? Uh, some more n number of nodes, right? So if I'm passing my current value as the maximum value, this this left whole subtree can get. So that means if for every child of this force left subtree, if if they are less than this particular max value, that means it's a valid BST. Or in another language, if you want to check if it's not a BST, then we say, hey, if any of these left child of 4 is greater than 4 at any point of time in our recursion, then just return false. Right? So that is recursing on the left child. And since it's a Boolean variable, we'll do and helper, hey, go to my right child. And here we'll pass min as our current value, max will be as it is, right? And why we are doing that? Let me give you an example. Let's say I'm recursing on child, right childs of the 4 node, or let's say I'm recursing on, you know, right childs of the node 5, right? So I am setting this 5 as the minimum value, right? So let's say if any value on the right side of this 5 node is smaller than the minimum value, that means it's not a valid tree. I mean, this is the smallest value in this whole right part, right? So if I'm passing this as a minimum value, then if any of this value of this node is less than that minimum value, I immediately return false. So think of it as this. If I'm recursing on a left child, then update the maximum value, right? To contradict the situation of a binary tree. Because at any given point of time, if binary BST is not valid, doesn't matter if it's valid on the next recursion, on the previous recursion, if any point in recursion, if the BST is not valid, we immediately return false. So that means when we are recursing on the left child, just update the maximum value. When recursing on the right child, just update the minimum value, right? And here comes our statement if condition to check, whether in which case should we return false, right? So here, if my root dot val, let's say I'm recursing on my left child, right? So if it's less than or equal to, since it's strictly mentioned that left subtree is less than, it doesn't say is equal to or something. So even equals invalidate our condition. So in this case, we are checking if, hey, if the root dot value is less than my minimum value, right? And who updates the minimum value? The right one, right? So if any, yeah, sorry, this is a recursion. Let's say if I'm on a right child of a particular recursive call. So if any point of time, if I am less than the minimum value, that means I'm on a right child recursion and my current value is less than my parent node. And that shouldn't be the condition. If I'm recursing on a right child, every value should be greater than the parent. So, or if I'm recursing on a left child, that is root dot val is greater than or equal to max, right? So when I'm updating the max in our left recursive call. So let's say if I am somewhere, somewhere here on my left child, right? And my current max is 5. And let's say this one node was supposedly 6 or something. If at any recursive call it's 6, that means 6 is greater than 5. So it invalidates our BST immediately because max is nothing but on our left recursive call, we are setting the max to our current node value. So at this scenario, we just return false, right? So this is the case when, we'll break and just pop false, 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 and false in every recursion call. So no matter what, let's say if I get a false here, right, and I got true till now, it will return false, return false, return false, return false, and false with anything is just false. So we will have to call this helper function and we'll say, hey, root not root dot val root comma integer dot min value comma, max value. Why we are setting that? Because for our base case, if let's say I have only one, one base tree, so if I match this root dot value to integer dot min value, it will always be the case, right? Yeah, I mean, it will never get inside this loop. Nothing, no value can be less than the integer dot min value. That's why I'm calling that. And let's run this. Okay. Uh, some Sorry about that. Let me clear some more things. Oh, I forgot to add the boolean return type to our helper since we are returning that, right? Oh, my bad. Let's also add return. Okay. Sorry about that, guys. So I think, yeah, there was a certain typo in this min value where I kept the L as a small letter, but yeah. See, this is running absolutely fine in our initial test cases, but I'll tell you, there's a test case. It will fail. Let's run it again just for the sake of it, right? And let me submit and show you what I'm talking about. See, if there's a big test case and a range of integer that, surpasses our integer min value or max value, it could be a problem. So what we can do here is, instead of integer, let's use long variables, and let's use long, and here also make it long, and this also long. Let's run the code and try it again. Alright, let's try to submit it. Okay, here we go, guys. So remember, always in the interview, tell the interviewer about your approach and then proceed. Talk out loud and think about it, what you're doing, and say it out loud. That's it. Thank you.